So hello everyone, my name's Joshua. I'm here to speak to you about CROSS, or cross space. And I'm going to be trying to tell a bit of an origin story as well as outline our future plans with the system, and basically how a honours thesis project started from 2017 when I graduated from Sydney University and turned into a proper payload and partnerships and continuous development. So I'm going to hopefully go through a bit of that journey. But who am I? So when I graduated from Sydney, I worked in Europe for about 4 or 5 years, working on position navigation timing systems, lunar comm nav services, alternative LEO PNT systems, and yes, I'm now doing my PhD at Sydney University and developing CROSS for optical navigation systems, and also have some collaborations with Royal Institute Navigation as well as the IAF Space Communication Navigation Technical Committee. But firstly, CROSS is a new type of optical navigation system capability, providing not only attitude determination star trackers, but also providing positioning and space situational awareness. And these are kind of our focus areas: accurate, secure. So obviously up in orbit today, the environment is becoming a lot more vulnerable to various malicious state actors, and what we are doing is utilising the architecture of a star tracker to also support a positioning capability that you can assure that the GNSS or tracking-based RF originated position fix is verifiable to something based on more of the optical-based spectrum using stars and celestial bodies to navigate. But also that has applications in domains beyond LEO. As you go beyond MEO orbit, you don't have access to the GNSS infrastructure, and you need to rely on optical navigation and other forms. Well, I'd say only optical. Quantum is getting there, but optical is really the only kind of autonomous reference source you can use for navigation beyond Earth orbits. So we're also applying it to other domains, as well as other research that has taken place from my colleague Julian in terms of spatial situational awareness, so utilising the architecture of a payload to provide, a navigation sensor to also provide space debris detection and be a supporting element to infrastructure to provide that. And we have a number of design values, providing novel software, customizable layout, small form factor, so applying it to the CubeSat, low cost and open source. But I kind of wanted to give a bit of an origin story towards how the project started. And this was actually the honours thesis in 2017. So essentially we got a smartphone and got a fully working star tracker architecture operating on it that you could get an attitude determination fix with the smartphone. And we had a bit of a vision. So this was kind of a passion project originally whilst I was working in Europe, to build basically a competitive star tracker platform, and trying to grow researchers, students through the University of Sydney, growing space capability for Australia. Star trackers are an essential component to most spacecraft missions. And there's huge supply chain bottlenecks. Talking to a lot of satellite companies in Europe, for example, they find it very difficult to actually source a star tracker, and it actually becomes a big manufacturing impediment for them to source a star tracker, given it takes about 6 months to a year to actually, from the procurement stage, to actually get it delivered. And there's not many suppliers of them as well, so there's kind of quite a big opportunity for it. And we wanted to develop the software and hardware to develop a small wide field of view star tracker, build partnerships with industry, disseminate the work, and kind of grow professional development of the members. And this is the stage we're up to now. So we have a fully developed Star Tracker payload platform with a baffle. One observation we have made is we need it to be coated. So in interior to the baffle, to actually make it usable, you do need to coat it with an absorbent material to avoid any sort of stray light interference. But it has been an incredible challenge to try and source that in Australia. We've spoken to, I'd say, about 10, 15 different companies providing coating, usually very enthusiastic and saying, yes, we can coat it. And then when we actually get to the stages of actually trying to get the coating, they've basically just said, oh, actually, we can't do this, sorry. Waste your time on it. But that is a key need, and if anyone's doing coaching in Australia, really, I think there's enormous opportunities that can be delivered on it. There's only 2 companies internationally that provide Star Tracker coatings. And that also is one of the big issues in the supply chain of Star Trackers. But we've got a fully developed payload, tested in laboratory simulation, but also night sky using the observatory at the University of Sydney on top of the Sydney Nanoscience Hub, and fully verified, good performances. And this is it inside the Quaver mission, Quaver 2. Well, it's actually the Quaver 1 bus that's been tested on, but the Quaver 2 uses the same, a lot of the hardware and software is the same. And these are the specs that we have quantified from the system. 10 arcsecond in the roll and pitch accuracy, so that's across the bore side, and yaw at 25 arcseconds, and these are the other performance characteristics we've properly quantified for the system. I would like to appreciate that we've received a lot of support internationally in terms of expertise. It's very much a research development project, so the international industry has been very helpful towards making sure the system is verified and competitive and making sure it's compliant with all the international standards, norms, practices of building a Star Tracker. And the current stage, as I was alluding to at the moment, is attitude determination, also exploring kind of open source sort of applications towards that. But then we're also looking at position navigation timing, which is to do with optical navigation, and then space situational awareness. And applying that very same architecture of the Star Tracker towards these additional applications, we're finding a lot of good success with that in terms of the simulation testing, but also external testing as well. And I would like to also mention that one of our other partners, Space Machines Company, is a key milestone towards us actually demonstrating this. So we've partnered with them to get it flown and launched and tested in space as well as Quaver 2. Yes, so there's myself, directors, and also Julian. Giving a shout out to Julian at the back. Well, I've also been supported by quite a significant, passionate, large team. And I wish to mention also, most of these people have actually graduated now, but they're also being still very much supporting and involved in the vision. And also a shout out to Eva and Xiao Peng, who've been key parts in developing this journey for us. Yeah, so I just wanted to give a bit of an origin and why, what is CROSS, what we've tried to develop from it, and actually now see the system being deployed on 2 upcoming missions and future partnerships, hopefully in the pipeline. Thank you.